Hello everybody, this is the video about how to do the adding and subtracting elimination method of linear systems. Before we get to that, I'd like to make sure you can still do what we did last class, which is substitution. These two questions here are substitution questions. I'll do one of them for you, but the other one you should do, and it's really the same process as what I'm about to do. So I'm going to do the first one. So it says y is negative x plus 3 and 2x plus 3y is 7. What this means is that the y in this second equation gets replaced with what y equals, and that is negative x plus 3. So that means what I would write as the next step would be 2x plus 3, not times 3y now it's times negative x plus 3 equals 7. Okay, and then we practiced this a lot last class. Now I have to do the distributive property of 3 times negative x plus 3. That is 2x, and that is minus 3x. That's plus 9, and that equals 7. Okay, now we have like terms to combine. There are like terms on this left side. 2 minus 3 is negative 1, plus 9 is 7. All right, 2 more steps to go. I got to subtract 9 from both sides. We get negative x equals negative 2. And then you would divide everything by negative 1. You find out x is 2. So that was the answer for that one. So that's basically what you do with number 2, but like you just replace the a in this second one with what a equals, which is 2b minus 1, and you just solve for a from there. The word problem for number 3, I'm not going to do it for you, but I'll help you translate it. So steak costs 3 times as much as a burger. So that means steak as an S is equal to 3 burgers. That's what that is. If I buy 2 steaks and 3 burgers for $18, how much does a steak cost? Okay, so that second part, the if part, is saying 2 steaks and 3 burgers are 18 bucks. All right, so that's how you translate it. I'd like you now to kind of use what I taught you to solve for steaks, which is, notice it says S is 3b, and that means this S down here can get replaced with 3b. And you can solve for burgers, and after you get the burger value, you multiply times 3, and then that's the answer. All right, here is a challenge problem. The sum of two numbers is 41. Their difference is 5. What are their numbers? This is a challenge problem that has a lot to do with what I'm about to talk about. We'll go over this later, okay? All right, so before we move into the land of elimination, there are words I want to say, and I want you to know what the heck they mean. Yeah, so let's see. Now, the big one we really want you to know is the word coefficient. That is the most important word of the day because that's the word I'm going to say a lot today. And so coefficient is a number multiplied times a variable. That's C-O-E-F-F. I-C-I-N-T. That is coefficient. All right. And the number in the upper right of the variable is called an exponent. We're not really going to deal with exponents yet in this unit. That's a lot afterward. Okay. So the number that is not being multiplied or divided by the variable is called a constant. Okay. Notice like this constant of minus 6 is just not being multiplied times the variable. It's being subtracted from it. And the whole math object, including variable, coefficient, exponent, whatever, is called a term, okay? We've done a lot of combining like terms so far in this class. So 5x cubed is a term, and also negative 6 is a term. They are different terms. They're not the same term. They are separate terms. All right, so really the focus is on the word coefficient because that's the key of this math today. All right, how to use the elimination method to solve linear systems. You recognize the common term. So what makes a common term is that they have a common coefficient. For example, like this one right here, 3x plus 4y equals 1, 3x plus 2y equals negative 9. The common term is the x's because they both say 3. So if they have the same sign, you add or subtract every time from both equations, solve for the remaining variables. Okay, so if they have the same signs, same thing, meaning like these are both positive 3, you subtract them. I'll show you what that means. And if they have this, if they have opposite signs, like this is positive 2 and this is negative 2, I would add them. Okay, yeah. So we're going to use the elimination method when they're both in standard form. like these are both like ax plus by equals c. Everything's ax plus by equals c. There is no isolated variables. And when you have no isolated variables, you want to do elimination. It's a lot quicker and easier. Yeah, so let me show you with this example here. Okay, so the variable with the common sign in the common coefficient is x. That's 1x, positive 1x, that's positive 1x. The y's are different. So what I would do is I would subtract them. Like you're literally going to subtract equations. X minus x is 0, okay? That disappears, but then negative 3y minus 2y is negative y. And then 7 minus 2 is 5. So that means the value of y is negative 5. And now that I know that the value of y is negative 5, notice the question wants you to find the value of x. You could plug that into either equation, either the top one or bottom one. It doesn't matter. You'll get the same answer. Let's use the top one. Why not? Doesn't matter. So that becomes 3 times 5 equals 7. Where would the z come from? There. Okay, so what that is I replaced the y in the top equation with 5 because that is what x is. Oh, x is negative 5, my bad. Negative 5. Okay, so what does that mean? X plus 15 is 7, and then if you subtract 7 minus 15 is negative 8, and you notice that's what D says, and that was the answer for what is x. All right, let me try a couple more examples like this. Well, before we get to examples, let's just kind of review the simple process of what do you do. We can subtract the equations if the coefficients have the same sign, okay, meaning the same or the same charge, whatever. So if they're both positive or both negative, you subtract. We can add equations if the coefficients have opposite signs, meaning like positive and negative are opposite of each other. So I'm going to show how to do these two examples. Okay, so again, we are subtracting and adding equations together. If you're in my class, I could show you in real life what that looks like, but it's hard to do on a video. But here we go. So I'm actually going to subtract these two equations from each other, meaning like they're horizontal equations, and I'm going to go vertically and down and subtract them. So 6x minus 6x is 0. They disappear. So I'm subtracting because they're both positive 6. 5y minus negative 7y is 12y. And then 4 minus negative 20 is 24. So basically, this entire extremely confusing looking problem got simplified down to just 12y equals 24. And then y is 2. And then to solve for x, you would plug that into either equation. I'm going to plug it into the top one. And like this, so that means, y is 2, and then 6x plus 10 is 4, and then 6x is negative 6. Why does it keep coming up? Oh, there it is. I actually capped everything, and then, doesn't matter. And then x is negative 1. So that would mean the coordinate that is the answer for that example would be negative 1, comma 2. Oh, why did 9 pop up? Yeah, so that would be the answer for that example. And now for the other example, what you do is what variable have common coefficients? Y does. They both say 3. The problem is one of them is positive and one of them is negative. So this would be an example of you would add them. So x plus 3x is 4x. Negative 3y plus 3y is 0. It disappears. 4x equals 9 plus 7 is 16. See how quickly we went to it? This giant ugly problem became very simple, very easy. X is 4. Now, since x is 4, I'd plug it back in. 4 minus 3y equals 7. So that means I replace this x here with 4. Then I would subtract 4 from both sides. Negative 3y equals 3. And then you divide both sides by negative 3. You find out y is negative 1. And that means your coordinates would be 4, negative 1. Yep, and that's how you do it. So really all 1, 2, 3, 4, 5, 6, 7, 8, 9, there are common coefficients where you just have to choose about adding or subtracting. And then you're brought down very quickly to the answer of one variable, and then you plug that into one of the equations to get the answer. That's how 1 through 9 works. Here are some word problems about this. I will help do one of them. Um, I mean, I should probably go back to the challenge one because that's a good word problem. And I'll do this and then we'll talk about one of the word problems. All right, so this one, all right, the sum of two numbers is 41. So you just pick out two random letters of the alphabet. Doesn't matter what letters you pick. A plus B. Sum means you're adding them is 41. And their difference is 5. That means you subtract them, you get 5. And now, based on what I just taught you, you can easily do this. And you can actually choose between adding or subtracting. It doesn't really matter which one you do. I feel like subtracting. And by subtracting, that makes the A disappear. B minus negative B is 2B. And then if I subtract those, I get 36. And that means B is 18. And if B is 18, A is 23. Yeah, and that's how you do that one. And then as for these, I'm not going to do all the math for you, but it'll help you translate one of them. Let's see, 10 or 11, 10 or 11. Let's do 10. So at the sale on winter clothing, Cody bought 2 pairs of gloves and 4 hats for $43. Tori bought 2 pairs of gloves and 2 hats for $30. What were the price of gloves and hats? All right, let's use the letter G for glove and H for hat. So that would be 2G plus 4H is 30. No, 43. What am I looking at? 43. Look at the wrong one. And then 2G plus 2H is 30. So that's what that word problem is asking to do. And then notice the G's have common coefficients and they're both positive, so you would subtract them. By subtracting it, 2H equals 13. And it looks like you're going to end up with something involving 50 cents, which is fine. So that means your hat is $6.50, and then you can plug that in and get gloves. And 11 is basically the same thing. 12, you don't even have to solve. You just gotta, which one of these 4 is the correct system that relates to what this word problem is saying. All right, that is it. I hope this is helpful. Have a good day.